You ready for something a little more fun?
No.
Not like the fake pizza party I gave you. Honest fun. That was fun though. That was good. No, not a real pizza. What am I, made of money? Come on.
Maybe.
A real pizza party? I'm made of money? Oh, please no, I'm not. Don't sell me. What we're going to do now is look at something that's kind of interesting. Actually, I'm going to warn you here. These look really hard. Are they really hard? No. No, everything that I'm about to show you, you've done before. But it looks really hard. What we do right here, what this is called a complex fraction. It doesn't mean complex because it's hard. It means complex because you have fractions within fractions. Do you see the fractions within fractions? Yeah, we got lots of fractions going on. Now, before we get going on how to actually do this thing, I need to identify some keywords for you. The keywords are this. When I say the main numerator, can you identify what fraction is on the main numerator? Very good. And someone else tell me what fraction is on the main denominator?
1/5.
Good. If I said the main fraction bar, would you be able to find it?
Yes.
Is this the main fraction bar?
No.
Main fraction bar. Is this the main fraction bar?
Yes.
This is called the main fraction bar. The big one. The main fraction bar. Hey, one more thing. When I say a fraction, what operation am I talking about? Am I talking about addition, or subtraction, or multiplication, or division?
Addition.
Fraction means divide. You all agree with that?
Yeah.
A fraction bar means division. That's supposed to be an M. So when I say something like this, I need you just to hear my voice and think about what I'm saying here. When I'm saying 7x over 10 all over 1/5, 7x over 10 all over 1/5, that all over, that's a fraction, right? And a fraction means divide, true? So what this really says is 7x over 10 divided by 1/5. Are you following me on that? 7x over 10 divided by 1/5. So would you say that if this is 7x over 10 divided by 1/5, this says the same thing as this?
Yep.
Yes. 7x over 10 divided by 1/5. 7x over 10 divided by 1/5. Do you agree it's the same thing?
Yes.
Hey, have you done division by fractions before?
Yes.
Absolutely. Do you flip the first one, the second one, or both of them?
Second.
So we can do this problem as long as you understand that a main fraction bar means division. A complex fraction is simply this. It's just a division problem. If we reciprocate or flip our second fraction, we get 7x over 10. Well, I'm sorry, what's the reciprocal of 1/5?
5, 1.
And are we still going to divide?
No. Multiply.
What are you going to do now?
Cross cancel.
No, not cross cancel now. You can do one thing before that. We've already flipped it. We've already multiplied. Say it louder. Make it one fraction. Remember that you can only simplify. I need you to really watch up here for a second, okay? You can only simplify if you have one fraction. You can only simplify if you have multiplication. I want to show you the difference between a couple of these problems. So firstly, you are definitely going to write 7x times 5 over 10 times 1. You agree? Look at the difference between these two problems. Can you simplify the 5 and the 10?
Yeah. Yes.
They're being multiplied, right? Can you simplify the 6 and the 3?
No.
It's not being multiplied. That's the difference. So here, multiplication, sure. Subtraction, no. No. Multiplication, absolutely. Subtraction, addition, no. This is where we could simplify. That's why, folks, I had you write it as one fraction to make sure you had multiplication. That's why I made you do the dots. Remember me making you do the dots? You got to do that. Over here, you don't have the dots, you don't have multiplication, you cannot do anything with that. That's the difference. Now we're going to look for common factors. You said the 5 and the 10, we're going to divide both by 5. What's 5 divided by 5?
1.
And 10 divided by 5.
2.
What am I going to have on my fraction, please?
7x over 2.
That makes sense to you.
Yes.
So with complex fractions, we understand division. We understand that it's really the first fraction, the top fraction, the main fraction, main numerator fraction divided by the main denominator. Write it out as a division problem, and then we have something we've already done before. We're going to make this a little bit more complicated next time. I'll show you how to do some of that. It'll be good. Well, let's review a couple key words about some complex fractions. Firstly, the complex. Complex doesn't necessarily mean hard. In fact, we've discovered that really we've kind of done these problems already. It just this is a different way of showing it. So complex doesn't mean hard, it just means fractions within fractions. Now, could you identify what the main numerator is? Which one of these is the main numerator?
X over 4.
Very good. So this is going to be our main denominator, 3 over 2. And the main fraction bar, that's the big one. That's the big fraction bar. That stands for division. All of these stand for division, but we want to represent this as one fraction divided by another one. So when we read this, sure, we have x over 4 over 3 halves. But what that really means is x over 4 divided by 3 halves. And in order to change this from a complex fraction into something we can deal with, that's what we have to realize. So our first step when we're finding a complex fraction, or when we're solving to simplify a complex fraction, is understanding that we can actually change this complex fraction into a division problem. This says x over 4 divided by 3 halves, and this says x over 4 divided by 3 halves. We have literally the same exact computational ordering right here. This says divided by, this says divided by. Same thing. Now, as soon as we do that, that's really the only thing I've taught you how to do in complex fractions, because we've already done this. We've done that stuff before. How do you divide fractions? What do you do next?
Flip it.
Flip what?
The division sign into multiplication.
So division changes to multiplication. Does anything else change?
You flip it to 3.
This one?
That, no.
This one?
Yeah.
Absolutely. We leave our first fraction alone. We change our division to multiplication because we know that division of fractions is the same thing as multiplication of the reciprocal of that fraction. Okay, what now?
Plus something.
Before you simplify, you're going to do this one little step.
Take one fraction.
Good, yeah. We know that in order to simplify, you have to have one fraction out of it, and it has to be multiplication. And I'm making you show this. I'm making you do this extension of the line, make that one fraction, and put the multiplication there. We spent a lot of time yesterday learning that you can't simplify. Focus up here. Learning that you can't simplify unless you have a plus or a minus. I'm sorry, if you have a plus or minus. You can only simplify it if you have multiplication on the top and the bottom. Do you remember talking about that? Yeah. Pretty much like for 10 minutes yesterday, I suppose. So the reason why I have you show this is the only time we can actually simplify is if we have multiplication here. Now this says, yeah, sure, simplify. Make sure that you take out common factors on the numerator and denominator. What numbers have common factors here?
2 and 4.
So we'll divide both of those by 2. That becomes a 1. That becomes a 2. You're divided by 2. Can you tell me what this fraction is going to become, please?
X over 6.
X over 6. And that's it. As far as we can go. So we changed this kind of nasty looking thing into a real nice simple fraction, x over 6. Raise your hand if you feel okay with this so far. Good. That's fantastic. I would like you to do one on your own just to make sure that you really get this, and then we'll move on. I'm going to start making these a little bit more complicated. It's not going to be any harder. We've literally covered everything that we're going to have to use for complex fractions already in this class. I just want to make sure that we can build up to those points. So try this one on your own, please. Okay, so we got this complex fraction, just means a fraction over a fraction. So when we're looking at this thing, the first thing we need to understand is that this actually is a division problem. So when we set up a division problem, we know that this basically means y over 5 divided by x over 10. Did you guys do that first step? Good. Now division, we know how to accomplish that. We know that in order to divide fractions, we keep the first one exactly the same, we multiply, and we take the reciprocal of the second fraction. Now we are going to simplify. We will. But before you do that, you need to show me one step. You need to extend the line and make that one fraction, because we know we can only simplify if we have one fraction with factors on the numerator being multiplied and factors on the denominator being multiplied. That's where we can simplify. So we show that step. Of course, we have 10 and 5, which have a common factor of 5. So we're going to divide both those numbers by 5. 5. 5 divided by 5 is 1. 10 divided by 5 is 2. How about the x and the y? Can I simplify those?
No.
So we're done with our simplification. We have 2 times y, or 2y, over 1 times x, or x. And that's as far as we can go. Raise your hand if you got that far.
Yeah.
Good for you. That's fantastic. It's really good. Now let's look at the next problem. Well, it looks a whole lot more complicated than this one. Tell me what's different about this problem compared to the ones that we've just done. Oh, that's right. There's 2 fractions over here on each the numerator denominator, whereas over here we only had 1 fraction over 1 fraction. Now the reason why this worked, hope you're paying attention up here, the reason why this worked was that we had 1 fraction over 1 fraction, in which case, when we wrote this as a division problem, we were able to flip over the second fraction, right? I want you to look up here for a second. Follow me along. If I have these 2 fractions being added on the top, this still means division. That's still our main fraction bar, right? It still means division. If I wrote this out as these 2 fractions divided by these 2 fractions, there's no way to reciprocate them. We can't flip both of them and have them be the same thing. It doesn't work that way. The only reason this worked is because I had 1 fraction over 1 fraction, and I could reciprocate it.
Do you solve it first before you do all the other steps?
Right. The only reason why this works is because I have the 1 fraction situation. If I have 2 fractions over 2 fractions, there's no way to reciprocate it. So what this says to you first is, you got to find a way to get 1 fraction over 1 fraction. Now, fortunately for us, I want you to take a look up here at the board. If you ignore this denominator, look at the numerator. Can you add those together?
Yes.
You will eventually. Can you do it right now?
No.
No? But what do you need to do?
Get the common.
Yeah, so what we're going to do, it's pretty much like 3 problems in one. We've done this problem before, we're going to add. We've done this problem before, we're going to subtract. After that, we will have 1 fraction over 1 fraction, we'll be back in this situation. Nudge your head if you're following me along on that. Okay, so that's our goal for this complex fractions. You must get 1 fraction on the numerator and 1 fraction on the denominator first. Then you set up your division problem. So let me write that down and then we'll start adding these fractions. So we're going to get 1 fraction on both the numerator and denominator first, before you start setting the division problem. So we're treating this like 3 problems in one. The first thing we got to do, let's look at 1/2 plus 1/6. We're going to ignore this main denominator right now. We're just looking at the main numerator. Can you tell me what is the LCD for 1/2 plus 1/6?
6.
Good. We don't want to work too hard, right? We don't want to do 12. That's too much. So I'm going to write out LCD is 6. Ladies and gentlemen, do I need to multiply this right fraction by anything?
No.
Do I need to multiply the left fraction by anything?
Yes.
By what?
3.
So from our main numerator, I have 3/6 plus 1/6. Do you see where those fractions are coming from? Okay, so from here, that's how we're getting this set of fractions. Now the main denominator, I also need a common denominator because I'm subtracting. Can you tell me what is my LCD for 3/4 minus 2/3? Notice how the LCD does not have to be the same. It really is like doing 2 problems in one. This is one problem. This is a completely separate problem. You don't need the same LCD. Nod your head if you're with me on that. Don't need the same LCD. LCD here was 12, yeah, for sure. What do I multiply the right fraction by?
4.
And somebody else, what do I multiply the left fraction by? Good. So these two fractions are going to make up my new main denominator. What's the left fraction give you?
12.
Okay. Someone else, what's the right fraction give you?
8.
So we've changed our numerator into 3/6 plus 1/6. We've changed our denominator into 9/12 minus 8/12. Are you okay so far? Okay. We're almost done. We really are. We're almost ready to make this a division problem. The only thing we got to do is combine these fractions. Look, this is just like adding fractions. This is just like subtracting fractions. That's exactly what we're doing. So if I do that, I know I'm going to have 3 plus 1 over 6. I'm going to have 9 minus 8 over 12. What's our top fraction going to be, please?
4 over 2/3.
So top fraction is 4/6 over, what's the bottom fraction going to be?
1/12.
Good. Hey, would you raise your hand and feel okay getting this far? Raise your hand and feel okay getting this far. Good, all right. So at this point, if you really look at it, we've just added fractions. You should know how to do that at this point. Didn't you just have some homework on that? Just learn how to add some fractions. We know how to subtract some fractions. You just had homework on that. So we know how to do this part and that part. The only thing I've taught you today and yesterday was going from here on out. We've already done that. We've done it a few times today. We did it one time yesterday. We just now need to set this up as a division problem, flip it, or reciprocate it, and simplify it. One question, and I think Tanya asked this, can you simplify this before you set up your division problem? Yeah, why not? Why not? If you wanted to simplify this little part of it, you certainly could, for sure. That's not going to change your problem. If you don't simplify it now, is it a big deal? Not really. You just got to make sure that you do simplify it at some point.
Well, you're still going to simplify when you do the multiplication.
You will.
When you flip it.
You're going to simplify it at some point. It doesn't matter. What I'm saying is it doesn't matter where you do it. You can do it here, fine. Just don't forget to do it later. You with me on that? You sure? Yes or no? I got to have something.
Yes.
What would you rather do? You want to simplify now or later?
Now.
Now?
Yeah. 2/3.
Okay. Whatever. You do now. You could easily write this as 2/3 over 1/12. You can simplify your fractions now. That's not a problem. Notice that if this had been a problem all by itself, you would have gotten 4/6, then you would simplify 4/6 as 2/3, right? So that's just fine to do that. No problem. Now we have 2/3 divided by 1/12. That's exactly what we're going to write. Two-thirds divided by 1/12. And we know how to divide fractions, so this is really a non-problem anymore. We know we're going to reciprocate the second fraction. We'll have 2/3 times 12 over 1. Well, you reduce 4/6. 4/6 is 2/3. Divide both the top and the bottom by 2, or write 2 times 2 over 2 times 3 and cross out those 2's. We should be able to do this with no problem at this point. So 2 times 2 over 2 times 3, 2's are gone. That's the intermediary step right there. Now, over here, we've reciprocated the second fraction. We'll extend our line. We'll put our multiplication. Does anything simplify out of that?
3 and 12.
3 goes into 3 one time, and into 12 how many times?
4. 8.
What are you going to get?
8 over 1.
8 over 1.
Or 8.
Or 8.
My God.
Now, question, are you going to get the same thing whether you reduce first or not?
Yes.
Absolutely. You're just going to have a little bit more simplification here to do if you don't change that to 2/3. You'll have 4/6. You'll have to simplify the 6 with the 12, and then you get the same exact thing.
What about that negative?
What negative?
Isn't that where the arrow's at?
That one?
Yeah.
Nope. The smudge mark. My bad. Better? All right. I was getting too excited and pointing out your math. I smudged it. My bad. Isn't it kind of amazing that this original problem works itself all the way down to 8? Isn't that kind of crazy? That's weird that that works. This is 8. If you had to pay a bill, you had to write a check out, you owed $8, you just write that. Here's how much I owe you. That'd be fun.
No.
I think that would be fun.
After you get a call from the bank, what do you do?
Learn some math. Take Mr. Leonard's Math 80 course, and you will learn how to do that. The numerator, first couple fractions that we're going to add. Of course, this is pretty much like 3 problems in 1. Are you guys seeing that? That we really have 3 problems in 1? We've got addition, we've got subtraction, then we have division. So it's incorporated in all of our fraction ideas right now. That's true, because division implies multiplication as well. So literally everything you learn about fractions you're using right here. Okay, so our numerator. We got to find an LCD. Of course, LCD is pretty much given to you. LCD is right here. It's the 8. Now, we're not going to multiply this fraction because it's already got the 8. However, we will multiply this fraction by 4 over 4. And what this is going to lead to is 4/8 plus 3/8. Did you get 4/8 plus 3/8?
Yeah.
Sweet.
Yeah.
On the denominator, we have just a little bit more work to do.
24. 12.
Which one are we going to use? 12, 24?
24.
Probably 12. I like 12 because it's smaller. That's the LCD. Would 24 work? Sure. Sure it will. But you're going to have a lot of simplification to do later on. So we're going to pick the smaller one. We're going to pick the smallest one that we can. 6 doesn't work. The next multiple is 12. That clearly works. This will multiply 2 over 2. This will multiply 3 over 3. And we're going to get 9/12 minus 2/12. How many people made it that far? Good. That's fantastic. After that, we're going to combine some fractions. Combine some fractions. Our 4 plus 3 over 8, we're going to get 7/8. Our 9 minus 2 over 8, we're going to get 7/12. I think I missed my intermediate step.
Yeah, that's what
If
I
you're
was
not-
gonna say.
If you're not sure on how to do that, that's what we're doing here. 4 plus 3 over 8, all over 9 minus 2 over 12. That's this step. Gotta make sure I show that working. We got 7/8 divided by 7/12. That's exactly what we're going to write out. It's 7/8 divided by 7/12. Now, of course, division means multiplication by a reciprocal. So we're going to leave our first fraction alone. We'll still have 7/8. We'll multiply by not 7/12, but 12 over 7. Of course, we must extend this fraction bar so that we know we're multiplying, and that allows us to simplify. We cannot multiply unless you have one fraction with multiplication, not addition, not subtraction, none of that stuff, just multiplication. What does simplify here?
7.
When I cross out the 7s,
1.
it's not 0?
No. 1.
Good, because we're actually dividing. Yeah, you're right. And the 8 and the 12, what goes into both those?
4.
2 times,
3.
3 times. 3 over halves, so let me see your hands if you got that. 3 halves. All right, good job. Good job. Bless you. We're going to try one more together. I'll give you one more to do on your own. We'll talk about some word operations, and that'll end our day today. Sound like a plan?
All right.
Well, let's look at what we got here. Now, we clearly have some complex fractions. Clearly have some complex fractions. But I want you to look up at the board with me. Let's focus in up here, folks. Guys in the back. We clearly have complex fractions because we have one fraction, another fraction, they're in a fraction themselves. But whereas in the previous examples we had a couple fractions on the top and a couple on the bottom, we had some weird things going on. First off, we have one fraction on the top. Now, that's actually a good thing, right? That's what we want. We want one fraction on the top.
Leave it alone.
Yeah, we're going to leave that completely alone. You're right. On the denominator, though, we've got one fraction and we've got a whole number. Can you change a whole number into a fraction?
Yes.
Put more than.
So really, when we have a whole number, we don't really have just the 1. I'm going to change that to 1 over 1. We're going to take that whole number, put it over 1. That makes it so that we have 2 fractions on the denominator. So we're going to leave the numerator alone. That's great. We want just one fraction. Denominator, though, we need to combine those before we do anything else. We can't do a division problem right now until we get one fraction with one fraction. Let's work on it. What do we need to do first for this bottom?
Common denominator.
Okay, someone else give me what is my common denominator?
5.
So same process. We got LCD of 5. We don't need to multiply this by anything. It's already got the 5. Over here, though, we'll do 5 over 5 because we know that in order to get 5 on the denominator, we need to multiply by that number. So 3/4 is good to go. On the denominator, we have x over 5 minus 5 over 5. Okay, I need to make sure you're with me so far. Are you sure?
Yes.
Okay, good. Good. I have a common denominator, right?
Yeah.
Can I combine those fractions?
No,
Why not?
there's no like terms on the top.
Okay, but can I make that as one fraction?
Yes.
Okay, let's do that. So we're clear that we have 3/4. I want you to watch what happens when you combine the fractions on the bottom. When you combine the fractions on the bottom, you've actually done problems like this before. I just graded your homework. Some people made a little math error here. I'm going to talk about that in just a second. You do have a common, ignore this top part for a second, all right? Ignore that. You do have a common denominator, so what is your denominator going to be here?
5.
5.
The thing I need you to be very careful of is what goes up here. What does go up here? X goes up there. What else?
Minus 5.
Okay, the minus sign goes up there. And what else?
5.
I have 2 questions. The first question is, can I combine those?
No.
I had a lot of people do that. A lot of people had like 18b minus 5 and gave me something like 13b. Can't do that. Okay, unless you have like terms, you cannot combine those. One's got an x, one doesn't. That's not like terms. One's a variable, one's a number. You can't take x minus 5 and get anything besides x minus 5. You just can't do it. Are you with me on that?
Yes.
It's like having x bananas and you take away $5. What do you have? I don't know. X bananas minus $5. They're not the same units. They're the same thing. You can't do that. Also, one last question. This is an important one for you. Can you simplify the 5s in this case? So can you just cross them out? Can I do that?
No.
Is it the same as doing something like this?
No.
It didn't even look the same. One has multiplication, one has subtraction. Can I cross out across subtraction? No. This is considered a term. When you have things that are added or subtracted, they're terms. You can't ever cross out or cancel out terms. You can factors, things that are multiplied together. So this is one situation where we can. This is one situation where we cannot. Hey, by the way, do we have one fraction over one fraction now? Yeah, I see one fraction. This is one fraction now, right? So
Yeah.
we can do the same exact process. Just watch carefully how this works. I'm going to move over here. You guys follow me if I move over here?
Yeah.
So we have got one fraction on the main numerator. We have one fraction on the main denominator. If we write this out, I want you to think of what it means. This is 3/4 divided by x minus 5 over 5. This is 3/4 divided by x minus 5 over 5. Hey, does this say the same thing to you that this does?
Yes.
Good, it should. It's the same thing. Can I still go through the process?
Yes.
Which fraction do I reciprocate, the first, the second, or both?
Second.
So I know 3/4 I'll leave alone. I'll multiply by, what's this fraction become? We're going to treat it the same way as any other fractions. We can still flip that over, still reciprocate it. Raise your hand if you feel okay with it so far. Good. The next step, this is the step you got to be kind of careful of. Okay, watch up here for a second. Now, when you extend the line, which I've let you do, You're clearly multiplying, right?
Yes.
Please watch up at the board here real quick. You're definitely multiplying the 3 times 5. You're definitely multiplying the 4 times something. But are you supposed to multiply the 4 just times the x, or the 4 times the entire x minus 5?
Sorry.
So am I going to leave it 4x minus 5?
No.
What should I have there?
4x minus 4.
Okay, what else could I show that as instead of doing that in my head? What do I do? If I want to show that I'm not just multiplying 4 times x.
Parentheses.
Good. Say that again.
You put parentheses.
You put parentheses. If I want to show that I'm going to show you the extra step in this case because I want you to see what happens. I have 3/4 times 5 over x minus 5. When I write this as one fraction, sure, I have the 3 times 5. But it's not just 4 times x. It's 4 times this entire thing. How I show times that entire thing, I've got to have some parentheses. I've got to have that. That says 4 times that entire expression, x minus 5. So whereas before you get 4x minus 5, you're not going to get that. You're going to get 4x minus 20, actually, if you were to distribute that. Now, I don't care whether you distribute that or not. You can, or you can leave it just like this. One last question. Can you simplify the 15 with the 5?
No.
What do you think?
No.
Is it being subtracted? Then you cannot. You're done.
Wait, so we don't distribute?
You can if you like. You absolutely don't have to. There's no reason that you have to distribute that unless it asks you to do that. You can leave it. That's called factored form. You can leave it as being factored. All right.
So you put in 4x and 4.
It's your choice.
Minus 20.
It's your choice. Do you guys have any questions on this? Because I'm about to erase it. All right. I want you to do one on your own. Then we'll move on to order of operations. There you go. Go for it. Remember, we're supposed to get one fraction on the numerator, denominator, then write a division problem, simplify.
just flip it? Flip it? Okay. That's better.
No, you have it backwards. Okay, let's bring it back up here. Let's focus in up here on the board. So first thing we know we need to do is get one fraction over one fraction. Now clearly we have one fraction on the denominator. That's great. That's what we want. On the numerator though, we have two fractions. We've got y over 5, and we actually consider this to be 2 over 1. In which case we know we need a common denominator. What is our common denominator here?
5.
Yeah. So we'll multiply 5 over 5. We've got y over 5 minus 10 over 5. The 3/10, we're just going to kind of drag that along. We're not doing anything with it right now. We're done with it. Nothing we can do. Now, the y over 5 minus 10 over 5, be real careful on that. We do have a common denominator, but when you combine that to get one fraction, our denominator is 5, but on the numerator, those are not like terms. You're just going to have y minus 10. That's all you can do. You can't combine it and get anything else besides that. Raise your hand if you got y minus 10 over 5. Good, that's fantastic. Really good job. All over 3/10. Now, we do have one fraction over one fraction at this point. This is one fraction, it's all combined. This is one fraction. We're now going to set this up as a division problem. Just make sure you write it appropriately. I know before, I kind of had these different. I had the two fractions on the denominator to start, and so we wrote that, when we did it, we wrote that first. But now, when we're looking at this is the first fraction. This is the main numerator. It comes first in your division problem. It doesn't come second. So we have y minus 10 over 5, and we're going to have that divided by 3/10. So we're going to write this out exactly what this means. This means this fraction divided by this fraction, that's what we have. Next up, we know division really is multiplication by the reciprocal of the second fraction. So we have y minus 10 over 5, and we're going to multiply by 10 over 3. By a show of hands, how many people made it that far? That's great. That's fantastic. Now, something kind of cool happens in this particular problem. I want you to look for it. When you do the multiplication, on the denominator, I'm thinking that you probably got 5 times 3. Did you get that?
Yes.
Because most of you probably extended your line, and you did that. One thing you must have, absolutely must have, what must you have? Specifically, I'm talking about this part. What is it? You got to have parentheses. Did you have parentheses? Did you?
Yes.
Okay. If you just do this, if you do that right there, that means y minus 100. That is not what you want. What this means is y minus 10 times 10. That's what actually we have. Y minus 10 times 10. Do you see where that's coming from? Now, this part is kind of cool. When you simplify things, you're simplifying items that are being multiplied together over items that are multiplied together. You can't ever subtract something that's being subtracted, simplify something that's being subtracted or added. So in our case right here, we could not simplify this 10 with this 5. Do you see why?
Yeah.
This one's connected by that subtraction. But what's awesome about this problem is that when we have those parentheses, it means that this, watch carefully please, this is something new you're learning right now. This is being multiplied by that number. Do you agree? This entire expression is being multiplied by that 10. And this 5 is being multiplied by that 3. What that means is that where I cannot cancel anything in here, I can't simplify anything in that expression, I could simplify the 10 with the 5. That is possible. Because this is being multiplied, and that's being multiplied. Do you guys see it?
Mm-hmm.
That's okay. That you can do. That's why we need those parentheses to show that. To show it's an entire expression being multiplied. If you don't have the parentheses, you cannot do this. If you do have the parentheses, no problem. You can do that. So here we'll simplify the 5 with the 10. What number goes into both?
5.
5 goes into 5 one time, into 10
2.
2 times. Are you with me, guys? With me? Okay. So because those are being multiplied by this entire thing, and 5 is being multiplied by 3, that's allowing me to simplify it. So I'm going to get y minus 10 times 2 over 3. Still so far so good? Now one more thing we commonly do. Commonly, it's actually uncommon. To see something with parentheses times 2, we will typically put this 2 in front of the parentheses. So instead of y minus 10 times 2, you'll almost exclusively see it 2 and then parentheses y minus 10. That's how you'll see things in every math class you see. Does it mean the same thing when I do that?
Yes.
Okay, multiplication is commutative, means I can switch it around, no problem. No, we had a question. That was it? Last thing we're going to talk about today, we're going to start some order operations. What was order operations that we've been doing so far?
PEMDAS.
Then what?
Exponents. Subtraction.
Oh, we are not of one accord right now. We are all choiry, not even. So what's the first one? Good. Then?
Exponents.
Then? Those go together. And then?
Addition and subtraction.
Good. And those go. I don't have 6 fingers, fortunately, but those things go together as well. So parentheses first for sure. Exponents second for sure. Multiplication and division as they occur from left to right. Then addition and subtraction as they occur from left to right. Let's try one of these with some fractions. See how it goes. Then we'll start on this next time. So 2/3 cubed minus 2. 2/3 cubed minus 2. The first thing we check for in any order of operations problem, whether they're fractions or not, is for parentheses then exponents. Now, we do have some parentheses, but inside the parentheses there's really no operation to do. It's just saying you have this entire fraction raised to the 3rd power. You follow me on that?
Yes.
If there was operations, we'd do that first. We have some exponents though. Now the question I have for you, we've talked about fractions that have exponents. Is that exponent applied to just the 2, just the 3, or both of them? Yeah, so the first thing we do, we leave this minus 2 alone. We're going to take 2 to the 3rd power and 3 to the 3rd power. That's what that says to do. It says both the numerator and denominator get raised to the 3rd power. Okay, now don't shout it out right away, but I want you to think of what 2 to the 3rd is. Don't say it out loud, just think about it. How much is 2 to the 3rd? 6 or 8?
8.
Good, because 2 to the 3rd means 2 times 2 times 2. That's 8. Now 3 to the 3rd, I want you to think about that one, don't say it out loud yet. 3 to the 3rd, is it 9 or 27?
27.
Good, that means 3 times 3 times 3, so 27 minus 2. So now we've got this down to 8/27 minus 2.
Put 2 over 1.
Good, 2 over 1, because now we don't have any multiplication or division, but we do have some addition or subtraction. This 28 over 7 minus 2, of course, yeah, we make that 2 over 1. Do we have an LCD?
27.
27.
That means we need to multiply this fraction by 27 over 27. We'll get 8/27 minus, hey, what's that fraction become? 27 times 2, how much is that?
54.
After we do this step, we're back down to subtracting fractions, which we've done in this class already. We've done everything here already. Are we okay? Can we subtract those now?
Yeah.
So we're going to have 8 minus 54 over 27. We'll go ahead and do 8 minus 54. We can change it to plus and negative, combine them with the addition rule. That's going to be,
Negative
say that again?
46.
46.
Negative 46 over 27. You would try to simplify it. You can't simplify that one. You're done. Raise your hand, feel okay with at least the exponent and the subtraction. Good, we'll try a couple more of those next time and keep on rolling. So we're continuing talking about these order operations, and we know that order operations means our PEMDAS, our parentheses, exponents, multiplication from left to right, then addition, subtraction from left to right, division, multiplication. So when we're doing with this, we know that the parentheses, that really is just holding the fraction there for us, but the exponents, that is important. So the first thing we do here is, of course, do our exponents. What I'd like you to do on your problem right now is eliminate the exponent for me. Go ahead and simplify that. When you're dealing with the exponent, does it go to the 4, the 5, or both the 4 and the 5?
Both.
Okay. Now, how about the 4 squared? Is 4 squared 8 or 16? Which one?
16.
Good. And 5 squared is?
5.
So we know we're going to get 16 over 25. Is there anything else I can do with this problem?
Make the 1 a fraction.
Let's do that. I want you to change this into a fraction, and then I want you to subtract them. So go for that now. So you should be making that into a fraction. Find your LCD, and then combine those fractions. Hey, how do you change a whole number like 1 into a fraction? What do you do? What was that?
Put a 1 on.
Okay. So instead of just 1, I'm going to change this to, well, just 1 over 1. Once you change that to 1 over 1, what's the next thing you must absolutely do in order to subtract these fractions?
LCD.
Good. Now, it's kind of nice when you have a 1, right? Because if you have a 1 as your denominator, the LCD is just the other denominator. So in our case, the LCD is 25. We don't necessarily have to multiply this one, but we do have to multiply this by 25 over 25. And we'll get 16 over 25 minus 25 over 25. Did you make it that far?
Yes.
Yes.
Okay. Also, if you really want to think about this, how much is 25 over 25?
1.
That's 1. So this is the same exact expression that we've been having the whole time, we're just writing a little differently. Now that we got that common denominator, of course you're going to make this one fraction. You'll have 16 minus 25 over 25. How much is 16 minus 25? That's it, as far as we can go. So we know that this expression is equal to negative 9 over 25. How many people feel okay with this exponent stuff? Let's move on. So we're moving on here. We got some exponents. We know how to deal with those now. Hey, would you be able to do that problem?
Yes.
What's the first thing you do on that problem?
Find the LCD.
Before the LCD even.
Move the negative. On
Yeah,
top.
let's move that. We move the negative. Now, if you can do that problem, so keep watching the board. I'm going to add to this. Can you do that problem?
Yes.
Yes.
Sure. Order operation says just do them individually because they're in your parentheses. Do your parentheses first, then check for exponents, multiplication, division, addition, subtraction. So when we have these order operations with fractions, it's not like we're doing anything new. We're just applying the old stuff and putting it all together with the order operations type problem. So let's do this together. I'll give you one to do on your own after that. Let's start with this one. Now the first thing Felicia said is, well, we don't really want to have a negative in front of our fraction. It's just a little harder to deal with. So we're going to take that negative, we're going to move it to the top, or numerator, of our fraction. So instead of negative 1/2, we're going to have negative 1 over 2. Now after you do that, after we move this, I'm going to rewrite it so you can see the steps. I'll leave this one alone because we're going to actually do that right now. With this problem, we of course can't add them right now because we don't have that common denominator. Can you tell me what is the LCD here?
10.
Good. So that means we're going to have to multiply, so we're going to write that LCD, 10. This by 2 over 2. And that by 5/5, that's going to give us a new set of fractions that has a common denominator. They're going to be equivalent, but we're purposely unsimplifying them for now. What's this fraction going to become?
5/10. Negative 5/10.
Plus how much?
2/10.
Hey, right there, we got a common denominator. That worked for us. That's exactly what we wanted to have happen. Now on this fraction, maybe we'll work this down to one fraction and work this one down. Does that make that work for you?
Yeah.
Let's do this all the way since we're on a roll. We've got -5/10 plus 2/10. Of course, that means we're going to have something over 10 because we know that common denominator doesn't change. I'm going to put -5 plus 2. That way we can see that it's not really a fraction problem anymore. It's really just an addition problem. -5 plus 2 gives you how much?
Negative 3.
Now we can finish this off. How about the 7/8 plus 1/8? Do we need to do anything there to find a common denominator?
No.
That's great. It's already got one for us. So we're just going to write this as 7 plus 1/8. That's going to be,
1.
8/8. Yeah, that's 1. Okay. We didn't really change anything on the right fraction from there to there. So here we've found our LCD after moving our negative to the numerator. We've used the LCD to find equivalent fractions. We have added those fractions together, we get -3/10. The other fraction was a little bit easier. We had 7/8 plus 1/8, they already had a common denominator. We make those one fraction, we add, we simplify, it's still 1. Hey, tell me something, what's it mean when you have -3/10 times, -3/10 and a 1 right there? What operation are we dealing with?
Multiplication.
What's going to happen then if we have -3/10 times 1?
It'll stay.
So it's there.
So what's our answer?
-3/10.
That's it, -3/10. So anything times 1 gives you that same thing back again. Raise your hand if you feel okay with this so far. Good. I'd like to give you one on your own. See if you can do the same thing. Very similar problem. There you go. So work through the order of operations. Deal with your parentheses. Then exponents, multiplication, division, addition, subtraction. If you finish with this quickly, if you finish that one, check out this next one, see if you can handle this. You got to really think about order of operations on the next problem, though. And I'll be walking around right now for just a little while. Should almost be done with that. If you need help, let me know. I'll go ahead and help you.
Are you sure? Should you write it over there or no?
If you can. if you finish with the first one, which is this one, great. Hopefully you were able to try that one. We're going to get to that in just a second. Let's go back to our first example though. We do have a couple parentheses. They're being multiplied together, but inside those parentheses is our first step to add those fractions with one another. And of course we have to find an LCD to do that. So in our first fraction we've got 1/4 plus 2/3. LCD gives you what out of that?
12.
Okay, so I'm going to rewrite it so we see what's going on. If our LCD is supposed to be 12 here, then we're going to have to multiply the 1/4 times 3/3. And we're going to have to multiply the 2/3 times 4/4. I'm going to work this fraction all the way down, then I'm going to work with this set of fractions over here. So on our left fractions, we've got 3/12. And of course, we're going to get 8/12. Did you make it that far, folks?
Yes.
If I combine them, now that we have an LCD, I get 3 plus 8 over 12. Or that's going to give me 11/12. So raise your hand if you got 11/12 for those first fractions. Great. Okay, now we got to deal with our next set of fractions. When we're trying to add 11/2 plus 1/4, what is your LCD there?
4.
Yeah, we don't want to pick something like 8 or 12. That's too big. It makes more work for us. Our LCD is already the 4. I just have to multiply this by 2/2. If I multiply that by 2/2, I'm going to get 22/4 plus 1/4. That makes the LCD for us. That means we can add those fractions together now. Of course, we're going to get 22 plus 1/4. 23/4. Would you raise your hand feel okay with this so far? Good deal. What now? Okay, so this does mean multiply for sure. We have 11/12 times 23/4. I'm going to move over here. Eleven twelfths times 23/4. How do you multiply fractions? Do you need a common denominator to multiply fractions?
No.
Don't waste your time. All we need to do is extend our line, make sure we have multiplication so that way if we can simplify, we can simplify. And then we look to simplify. Can you simplify those numbers?
No.
You got 11 and 23, which are both primes. You got 12 and 4, which aren't, but they don't have any common factors with 11 and 23. So can you simplify them?
No.
No. You just got to multiply them. How much is 23 times 11?
263.
253? 253?
Yeah.
12 times 4, I can do that one.
48.
253/48. Raise your hand if you got that. Raise your hand if you got all the way down to here. Okay, that's good. That's good. That's almost everybody. That's fantastic. Would you like to do that problem?
Yeah.
It's kind of fun. We're going to do this right now. Now, you got to be pretty darn good at order operations and not let yourself be tricked by a problem like this, because it's not a tricky problem. It's not meant to be a tricky problem. But you know what? A lot of people actually make a mistake on that problem. You know what a lot of people do on this problem? They think order operations, and here's the process that they do. They go, okay, parentheses. Well, I don't have it. No problem. Exponents. Well, I don't have it. No problem. Multiplication. Oh, I got multiplication. Let's do multiplication.
No. You guys do division.
But that's a
That's
mistake
right.
people make. People make this mistake all the time. I need your eyes on the board here real quick, please. People do this all the time. They'll go, oh, well, this is a pretty easy problem. This is 5/6 divided by 1/12. Can you see how easy that would be to do? If you're going fast, or if you really don't get the order operations, or if you really think that multiplication comes before division all the time, you're going to do that. Are you getting the right answer?
No.
Definitely not. No, you're not. Because right now, you'd be multiplying by 12/1, right? You'd simplify the 12 with the 6, you get 5 times 2, you get 2/1 is your answer. If you did it this way, you get the answer 2. What we're going to get next is the correct answer, and it's not going to be 2. So this way, not so much. Can't do that. what is the appropriate thing to do? If we're not supposed to multiply first, what are we supposed to do?
Divide by
Divide.
6 by 1/3.
Because order operation says parentheses exponents, we don't have those. Multiplication, division. But that's not multiplication necessarily in front of division. What it means is you check out those two things, and whatever one comes first from left to right, you do that first. So whereas this looks like you're supposed to do multiplication, no, division came first. Those two things are tied together. You do whichever one comes first left to right between division and multiplication. So in our case here, we're going to ignore that 1/4 for a moment. Just a moment. And we're going to go, okay, ignore that. Can you do that problem?
Yeah.
That's the first thing you're supposed to do. This is supposed to be 5/6. And then what do I do with that 1/3?
Times
Times
two.
the
Flip
2.
to 1/3.
Okay, that's called a,
Reciprocal.
good. And instead of dividing, I am multiplying.
Huh? Do that, then that, then that.
So do you multiply first? No, not in this case. Not in this case. You divide first. You divide first. Not this one. This one. Divide first. Ignore the 1/4 for just a while we handle this part of the problem. And now, if you'd like, you could put this all together, right? You have multiplication of fractions. That's
You can
fine.
multiply it all across, like all
You can.
numbers?
Yeah, you can. You can do one of two things. You can either say, oh, this is multiplication. Do you need a common denominator to multiply?
No.
So you're multiplying two fractions here. Here's option one. Option one is you extend your line, put the dot dot. Extend the line, put the dots, so we are now multiplying. Can you simplify some of those numbers?
Yes.
Yeah, that's 3
That's it. That's all you'd be able to simplify. You'd multiply what's left over. Or, going back to here, you could do these two at a time. You could do the 5 times 3 over 6 times 1. Simplify this fraction, and then put the 1/4 next to it and simplify that one as well. That just takes a little bit more time and extra step. Which one would you rather do? Would you make one big line or do this two fractions?
Big line.
We'll do the big line. I'll show you both, as a matter of fact. So here's option one. Option one is 5 times 3 times 1 over 6 times 1 times 4. Make one big fraction out of it because it's all multiplication. Or, you don't have to do both, just choose one. You're going to do 5 times 3 over 6 times 1, and hold off on that 1/4 for just a moment. In either case, I need you to notice that you're going to be able to simplify this. The 3 and the 6 do simplify. Why? Well, because I have it multiplied. It's not added or subtracted, it's multiplied on both the numerator and denominator. 3 goes into 3 one time, into 6 2 times. Are you getting pretty good at that, I hope?
No.
This is going to be 5 times 1 times 1. This is going to be 2 times 1 times 4. You're going to get 5/8. That's our answer for that version of it. Now we should get the same thing over here. Let's see if we do. Here, the 3 and the 6 will simplify. 1 and 2, you get 5 over 2. This gives you 5 over 2. However, you still have 1/4. Do you see it? Extend our line. 5 times 1 over 2 times 4. Nothing simplifies. You still get 5/8. Same exact answer, done two different ways. One way is a little bit more concise. Since you have multiplication of all 3 fractions, put them together and simplify. If you like the 2 fractions at a time, that's not a problem. Do it that way. How many people feel all right with this so far? Okay, good. Now I'm going to give you one more. So it's pretty much everything encompassed in this problem, well, with the exception of some division. I want you to see if you can handle this. I'm going to put a problem similar to that on your test. That says 3/4 plus 1/8 quantity squared minus 1/2 plus 1/8. I'm not going to do this with you. I'm going to have you do this on your own in just a moment, but I want to talk about it first. What's the first thing you might want to do here?
The parentheses.
Definitely parentheses. Do I want to deal with the exponent right now?
No.
No.
I want to figure out this as one fraction first. I want to figure out this as one fraction first. Then I'll be dealing with my exponents. Then I'll be dealing with my subtraction last. Go ahead and try that on your own. I'll be walking around. If you need help, you let me know. I'll help you. Also, there's no need to rush through this. Show your steps. I'd rather have you be slow and right than quick and wrong, okay? Did lots of good work so far. That's really good. We're going to start up here in just a few seconds. All right, hey, let's see how this thing's done. So, firstly, of course, parentheses come first. We're going to deal with those fractions inside of those parentheses, make it into one fraction. So basically, we're going to have several problems in one. We've got one problem, two problems. After that, we'll have something to an exponent. That's three problems, and then a subtraction problem. So we'll deal with our first couple fractions. What's our LCD for the first two?
8.
I'm going to extend that a little bit. So we're going to multiply this by 2 over 2. We'll get 6/8 plus 1/8 squared. Gentlemen, you with me? Minus, what's the LCD for our next couple
8.
fractions?
8.
So here we'll do 4 over 4. And we'll get 4/8, 1/8. Cool, now we'll be able to combine those fractions together. If we do our first couple, we're ultimately going to get 7/8. We have 6/8 plus 1/8. We're going to do 6 plus 1 over 8. Notice how we're not dealing with the exponent yet. Not yet. We got to get one fraction first before we do the exponent. And we're going to do 4 plus 1 over 8. So put those together. You cannot do this. You cannot take this to a power and this to a power. It doesn't work. You can't do it. It's not legal mathematically. So you cannot square 3/4 and square 1/8. You have to put those together in one fraction before you square them. Is that understood? The parentheses have to come before the exponents. Otherwise, you've done exponents before parentheses, you're going to get that problem wrong. So we're going to get 7/8 squared minus 5/8. And I don't really need the parentheses anymore because I've done that problem. I have one fraction now. How many people made it that far? Just show hands. Good for you. That's fantastic. All right. 7/8 squared. Does a 7 get squared? The 8 get squared, or both?
Oh,
So we're going to have 7 squared over 8 squared.
Does that happen?
Just a reminder, when you're squaring a number, it doesn't mean multiply by 2. So when we're talking about 7 squared, you're not supposed to get 14 out of that thing. You're supposed to get 7 times 7, or 49 out of that thing. Same thing with 8 squared. You're going to get how much? Well, not that.
64.
Get 49. And what was the 8 squared?
64.
Oh, we're almost done. The last thing we've got to do is somehow find a common denominator so that we can subtract those fractions. Can you tell me what is my common denominator?
64.
Yep. So if we multiply by 8 over 8, we'll get 49. 49 64ths minus, what's the 40? Oh, sorry, what's the 5 8 times? How much?
40 64.
So we're going to have 49 64ths minus 40 64ths. So we got that common denominator. We'll put them together as one fraction.
49.
And lastly, we'll subtract. 49 minus 40, of course, we're going to get 9 out of that. How many we got 9 64ths? Good. If you worked all the way down, that means you know your fractions and you know your order of operations. The only thing that wasn't up here was multiplication division. But if you can do this problem and you can do that problem, that shows me you got a pretty good understanding of what's happening in this class at this point. If you were successful on both of them, congratulations. That's pretty good. Do you feel okay with it?
Yep.
That's pretty intense, right? That's a lot of stuff going on. But is this anything you haven't done before?
No.
Really? I mean, what are you doing? You're adding fractions and subtracting fractions sometimes? You're doing exponents, we've done that. Multiplication, division of fractions, we've done that. It's just piecing it all together. The only problem is you have to be rock solid on every piece, otherwise the end answer is not going to be good enough. Not going to be right. You mess up one little spot. Those are the problem. Do you feel okay with the complex fractions or operations? Can we move on for you?
Yep.
Are you ready?
That's good.